Okay, to start having an understanding of extreme value theorem, we'll do something that we already know how to do, which is define relative max and mins. So for this example, Part A wants us to find the intervals of increasing and decreasing. Part B wants us to find the extrema. They're related because you find the extrema from what the graph is doing. So we need to find the first derivative first, and we're going to set that equal to 0. That will give me my critical values, and I'll do my sign analysis, and I'll find my intervals of increasing, decreasing, which then will lead me to my max and my min. All right, we're going to set that equal to 0. I notice there's a GCF of -3, so I'm going to take that out. That leaves x squared plus 4x plus 3 is equal to 0. And we're now going to factor this. Now normally, like back in pre-calculus, we can go ahead and ignore this -3 because we're looking for zeros. We're not really looking for zeros. We're looking for critical values. So we do need to keep that -3. It's going to be important when we go to do our sign analysis because this is of the original function. So it's going to be +3 and +1, which gives us two critical values of -3 and -1, and then we'll test to the left, to the right, and in between. And when you, let's do 0 for example, because that's going to be the easiest one. When I plug in a 0, I get 3, 1, that's positive, but there's still this -3 here, so that is going to be a negative. When I put in a -2, I get positive, negative. That's a negative, but there's still the -3 here, so that's going to be positive. And then I do the same thing for here, and I get negative. All right, so now I can answer my intervals of increasing, my intervals of decreasing. So f is increasing on the interval -3 to -1 because, and then just like we've been doing for the last few weeks, we know the reason. I'm not going to write it just because I'm lazy, but you need to. It's your notes. Because f prime of x is greater than 0. We've been doing that forever. So we can do the same thing for decreasing. F is decreasing. This time it's decreasing on two different intervals, so we need to union that. From -∞ to -3, unioned with -1 to infinity. And again, just like in the increasing example, they'll come up with a reason as to why it's increasing. All right, which is going to lead us down to part B, which says determine the coordinates of the extrema and why. And so we can now say that f has a relative max where our graph changes from increasing to decreasing, so at -1. And f has a relative min where it changes from decreasing to increasing, so that's going to be at x equals -3. Now you have to read the directions because this problem does not ask us to find the x value, it asks us to find the coordinates. So that means I now need to figure out what is f of -1 and what is f of -3 so that I can give my coordinates. And so I'm just going to plug them in, and I get a 6 for -1 and a 2 for -3. So I'm going to fix that now. I'm not going to do it as x equals. I'm going to change that to a coordinate point. F has a relative max at the coordinate point -1, 6, has a minimum at the coordinate point -3, 2. And then you should give your reason of because of something to do with the derivative. All right, you could go ahead and pause it and kind of fill in all your reasoning if you want before you continue. Totally up to you. Okay, now part C wants us to sketch the graph on a closed interval. That's really important that you understand that it's a closed interval. So in order to do that, I need to figure out how high the graph is at f is -4. So if I type in -4, plug in -4 into my function, I find out that at -4 the function is 6. And then I need to figure out, all right, where is it at 1? Now when this is an open interval, we don't care about those, but because it's closed, those points actually matter. And this goes down to -14. This is 6, that's -14. All right, which is, if I scroll down, a little too far, right there. All right, now earlier I found out that I had a relative minimum at -3, 2, and a relative maximum at -1, 6. So now I can get a rough idea of what this sketch looks like. Okay, something like that. Now we are going to be talking about this concept of absolute. So you have relative minimum, relative maximums, but you also have absolute minimums and absolute maximums. Those are pre-calculus concepts. Absolute is on a closed interval. Relative is on an open interval. So now when you are looking for the absolute value, you have to consider the endpoints. If the endpoints are higher or lower than your relative max or mins, they become the absolute maximum or absolute minimum. I'm hoping that makes sense. So as I look at D, it says find the absolute maximum on the closed interval from -4 to -1, and the value at -4 is 6. The value at -1 is 6. So both of those become the absolute maximum. Now over here on C, it says identify the absolute minimum. I have a relative minimum at -3, 2, but the graph goes all the way down to -14 when it's at -1. So that becomes my absolute minimum, -1, or +1 and -14. Now as I was looking at notes, I think I might have wanted to talk about something else here, but I realized I typed the exact same thing as D and E, so we will skip those. Sorry.